Here we are, Straight Fire 21, going back into looking at congruent triangles, one of the more important themes for the course. So let's take a quick look at this video lesson. Looks like it's involving reasons for triangle congruence. It looks like there's a proof, but no picture. And I guess that's all you get for episode 21 is just a quick reminder of some of the thoughts and themes from most likely the fall. So let's take a look at each of these questions. Pause it and then hit play when you're ready. So let's take a look. The very first question. Well, they give me some facts about the lengths of these sides. They're saying that AB is the same as AC. So I know I've got an isosceles triangle. I also know that the base angles are equal without them having to tell me that. Once I know that we've got equal sides, I know that there's got to be two equal angles. So I'll color those in red. So that red angle there is equal to the red angle here. And the two blue sides are the same. What else do I know? I know that BD is a third of the size of BA. So this white is a third of the entire blue side. I also know that CE is a third of CA. Well, the blues are the same, and if the whites are a third of each of the blues, then the whites have to be the same. So I'm getting all those facts, and now that I'm ready and I've got everything colored, I can actually take a look at what the question's asking me to do. So it says triangle EBC. Alright, so EBC is just this little one here. They're saying that it can be proved congruent to DCB. So, oh yeah, so let me mark it up. So they're saying that the triangles that are polka dotted have to be congruent for a particular reason. Well, concentrating only on the polka dotted triangles, the yellow one and the black one. What do I know about the parts of the yellow polka dotted triangle and the black one? Well, I do know that the yellow one has the white side and the black one has the white side. I know that the yellow triangle has a red angle and the black triangle has a red angle. And I also can see that there are some other things that are the same in the picture. I know that these angles are the same because of vertical angles. However, this angle right here is not one of the three angles of the black triangle. And this angle here is not an angle for the yellow triangle. The yellow triangle's angles are up here at E, down here where B is, and over here where C is. So it's not wrong to say that these angles are equal. It's not wrong to say that these angles are equal. They're just not helping me. The angles and sides that are going to help me the most are the ones that belong to the black triangle and the yellow triangle. Some teachers tell their students to take the triangles and separate them. I've never been a huge fan of that. But if you separated triangle DBC, either in your mind or you just sketch it out like I'm doing here, I can even color code it too. I can also remove the yellow triangle from the picture too. And I guess this maybe does help a few students, but I always feel like untangling these triangles doesn't really seem to get me much farther than when they're tangled up. But if I color code it just like I did before, I may have an idea of the pieces that I've got. It might be easier for me to see how this finishes. So these are the sides that are the same. These are the angles that are the same. And there's one more side or angle that must be the same. And I don't know if it stands out to you or not, but BC and BC are in both triangles, so those would have to be the same as well. And that would finish up our side angle side pattern. You could have also seen it without separating the triangles, that the two triangles are glued together on side BC. They're sharing that side. So the BC in the black triangle is the same as the BC in the yellow triangle. So the triangles can be proved congruent by side angle side. All right, digging into the last two. Yeah, there's only two more questions. Which statements could be used to prove the two triangles are congruent? All right, well, there's no picture here. So maybe the picture might be a good idea. And what I'll do is I'll just set up a line right here. I'll draw a triangle, call it triangle ABC, and I'll reflect it over this line to create another triangle, A prime, B prime, C prime, the image of it. So I might have to erase as we go, but I'll use the colors to help see it. So which one could be used to prove it? Well, if we knew that those two sides were the same, and we knew that these were the same, and we knew that these angles here were the same, that would not be one of the 5 methods that can prove triangles are similar. That would come out to be an angle, a side, and a side. And then ASS does not prove triangles are congruent unless the angle is a right angle. So I know that it cannot be choice 1. So is it choice 2? If AB is congruent to A prime B prime, if angle A is the same and angle C is the same in both, then would that be one of the methods that are valid to prove that triangles are congruent? It is. That would spell AAS. Angle, side would be one of the ways to do it. So if I had more time, I definitely would check those other ones out to rule those ones out for sure. But it is choice 2. And then we're looking at the last one here. No picture again. So in triangle BAT and triangle CRE, we know some facts are true about those two triangles. Write one additional statement that could be used to prove that the triangles are congruent, and then state the method that would be used to prove that the triangles are congruent. So so then again, I'm trying to prove that the triangles are congruent. So I'm just going to attempt to draw 2 triangles that look congruent. So one nice way to do that is just make one a translation of the other. I guess I could cheat and make them look perfectly congruent by copying and pasting, but I'll do it the old-fashioned way, which is just to sketch it out and not cheat. So I got triangle BAT, and they're giving me some facts about triangle BAT. They say that if you compare triangle BAT and CRE, angle A and R are the same. So I'll put an R here. It says that BA and CR are the same. So it must mean that C belongs there. And that must mean that E is this last one. So angle A is the same as angle R, and BA is the same as CR. So I need one more piece, one more part that could complete the triangle congruence? Well, side, side, side would be a possibility, but since I've already got an angle and a side, there would be a faster way to get there. I could do a side angle side if I knew that AT was equal to RE. So naming a part, what part could be used is that AT is congruent to RE. And then what method would prove that the triangle, or what reason would prove that the triangles are congruent? Side angle side. So it's one possibility. We could have done angle E is equal to angle T, and then used angle side, just like in the last one. You could have said angle B is equal to angle C. So there's another possibility. Angle B, if angle B was congruent to angle C, then you could be using an angle side angle as a method to prove that the triangles are congruent. So yeah, basically for this question here, there's a couple different directions to go. You could either use 3 different directions to go. All right, well, that pretty much wraps things up for 2018-2019 for the Straight Fire math series. We'll see if we maybe could possibly continue this in the future. And if you stayed with me from episode 1 all the way up through 21, that's fantastic. And you just did yourself probably a huge favor in terms of getting yourself prepared for your exam. And this, strengthening your memory on these things is important. And there's been, of course, a lot of material throughout the year. So opportunities like this, the fact that you can seize the chance to do this, you should really feel good about yourself that you've pushed yourself and stuck with it enough to try to make the difference. So good luck to you, and maybe we'll catch you on a future installment of Straight Fire Math.